Welcome to yet another video. Today we are going to discuss on microservices design pattern. So we are going to discuss all the design pattern majorly used in the microservices. So whether you are preparing for an interview, whether you are here for learning microservices, what exactly it is and what are the design patterns. This is a must watch video for you all. So the very first design pattern is about API gateway. So if you have heard of the microservices components, so this is one of the important component where all the request from the client lands on this particular API gateway, and then it goes to these services. So it acts as a single point of entry for all the clients which is going to interact with the microservices. Now it in general it the request, it handles the request which is going to route to the which is going to the appropriate microservices. So it can act as an aggregating response, and then it provide features like load balancing, security, and authentication. So it simplifies your client communication, and also it reduces the number of requests which is going from the client to the services, right? So it simplifies it, right? So here the involvements of like three things: one is the client, and one is the gateway, and one is the microservices or the backend. So the client is going to request it, and the API gateway is going to be in the central part where all the incoming requests will be passed through it, and then it processes that particular request to the appropriate services. It can also aggregate some or the responses or handle the authentication, rate limiting certain requests, right? Now it comes to microservices, the various services like there are backend database services the gateway interact with, right? So that can be things. Now this is one of the important design pattern. So you must have heard of like each microservices will be have their own databases. So basically it will have its own dedicated databases, so that there is an data, so it ensures that there is some data autonomy, and then also to avoid some tight coupling between the other services, right? So which will achieve some data isolation as well as the scalability when it is required for each microservice. So it will not be restricted when there is a lot of request which is coming, right? So if you see here, the client is there, the API gateway is there, and from that each there are two microservices which are having two different databases for each one. Talking about service discovery, so basically this will allow your microservices to find each other. So basically it will dynamically load and then discover it, and especially in different environments where the services are getting scaled up or scaled down based on the number of requests, with the help of Kubernetes or the cloud environment. So it ensures that microservices can be discoverable, and then also they are communicating with each other, so that without knowing their addresses, they can communicate with the help of the service name. So if you see here the client and there is a load balancer, and then there is a service registry, and if you see the service microservices are going to register in the microservices. Circuit breaker design pattern. Now this is one of the important design pattern when it comes to handling the failure of an microservices. So it will gracefully handle your failures. So if there, let's say there is some failure which will prevent the failure of microservice, which will from cascade into the other services. So right, so by monitoring like just the calls which are going to the services, and then it will open the circuit and the services is unavailable. So it will, what the main purpose of it is that you want to enhance your system resiliencies and also reduce some downtime where the services are down. Now basically this particular design pattern is used to for fault tolerance, and then it will prevent the systems from being repeatedly trying to execute certain operations that are likely to either fail or like or purposely done by the hackers, right? Now when the service or the operations which are going to fail too many times, right, then the circuit breaker, what it does is that it has got three states. Out of that it will open the circuit, and then the any further items which are requested, or like the service is right, it will be blocked until that, allowing that system to recover its by own until that particular proper system is properly been up. Now, as I mentioned, there are three states: closed, which means the operation is attempted as usual, so there is no problem. Open means there is some operation is blocked currently after some certain failures which has happened, and it will prevent certain overload on the system. So it will completely block the request. Half open, this system will see if the operator can handle the request and it can succeed some of the request. If it succeeds, then it will closes the circuit, or else it will again wait for some time. Now, this basically is used for cascading failures, and also it allows the system to be maintained its stability by temporarily halting certain requests. Event sourcing pattern. Now, in this particular design pattern, instead of persisting at the current state of that particular data, it is going to store in the sequence of events basically. So this is going to lead uh, in a continuous event sourcing manner. So it is ideal for the applications, let's say where you want some high availability and reliability, and also ability to reconstruct some past related states actually. Okay, so it involves sequence of events which would rather than storing in certain, I would say, transition or a kind of state being built up, right? So that's where we can use it. Now, instead of updating the database, what we can do is that we can record it into the other event. The system will reconstruct that particular current state from the start itself, basically. So that's the benefit. So let's say you want to provide some audit trial or the changes, right? Or you want a recovery or the debugging by replacing certain events, right? So that's the benefit of it. Now what happens is that, like, the services is going to communicate certain events to certain event store, and services, other services, going to consume it from that particular service basically. Now, CQRS commands, the command and the query and the responsibility segregation. Now what happens in this is that a separate method of reading and writing the data happens, which allow for optimization of each operation. So basically, there are heavy reads and also there are heavy writes, right? So it will be useful in a system that have distinct demand, basically, where there is more query or whether there is more of updating happening, right? So it will segregate your load, and then it will segregate your system basically. Okay, so separating that particular read and write operation of a system into a distinct model will give you a better performance, and also it will handle the operations. Let's say for the command, right? So it is going to handle the modify commands which are going to process through a certain command, right? And then there are different. The other one is the model query, so which is going to handle all the operations that are going to retrieve to certain separate query model. So uh, in this, we will have a quite optimized performance for reading and writing, and it will improve your scalability, maintainability, etc. by allowing certain specific purposes. So here is a diagram. If you see, the client in the UI is going to request separate command in the query, and it is going to write and read in the different databases, right? So this is how it is achieved. Saga design pattern. So basically, this is basically used for the long transaction that will continue, that either will coordinate with multiple services by either ensuring that each services perform its activity, its own activity as a part of a transaction, or but basically if it is going to fail, then they are going to trigger and compensating action on it. Now, basically, this is used for managing the distributed transactions and also to maintain the consistency in the microservices. Now, there are two kind of approaches basically which is going to handle the distributed transaction. One is using the choreography and one is using the orchestration. Now, orchestration is something which is going to be centrally managed, and there will be a sequence of steps involved in it. Now, the orchestrator will tell each services basically, right? the central coordinator, what to do and in what order, right? So that will be coordinated by the central coordinator. Now each services will going to complete will its own part, and then it will inform the central coordinator. Now let's say, just an example, dedicated services which is a saga orchestrator, which will send a command to the other microservices. This is how it will be communicating. Now when it comes to choreography, there is no central coordinator. Instead, what will happen is that each services will act its own, and then it will communicate with the other services, right? Now each service will listen to certain events and from the other services, and then it is going to respond accordingly. Now, let's say service emits some events to indicate their statuses, right? Now, other services will, based on that particular event, whatever it has been published, will publish those old events or actions just to be taken by its own self. Uh, so orchestration make use of the central coordinator or a controller, while choreographer which will rely on each event communication between the services, basically. Now, strangler fig pattern is basically is going to is nothing but a gradually which is going to replace the legacy system, right? So we are modernizing the application, so we are certainly replace certain components of the system by building a new microservices, which will be designed around the old system only, and it will be done in the incremental manner. So it will be migrated slowly according to the functionality. Now, from monolith to the microservices, this will be a incremental change, would say. Now, in this particular strategy or pattern, I would say, we are going to gradually migrate, right? Or suddenly, we are trying to replace certain each components with one by one, and that's what the triangle, the old incremental it means, right? Uh, so it is going to build around the system, around the functionality, and slowly the traffic will be moved from the old system to the new system until that the whole system is completely replaced by the new system. Now what you can do is that by you can start implementing certain new features or services that will basically run in the parallel, right? So it will uh, over the time it will some part of the old system will be replaced one by one, certain it will be done gradually until that one day the finally all things, actually whatever it was there in the legacy system, is replaced by the new entirely microservices or the system. So you can make it in the phase wise or incremental manner. That's how it is going to work out. So client side load balancing, basically it is used for determining which instance of the microservice is going to call, or based on the list of available instances are there, right? So it is going to determine. So uh, that's how we used to in the distributed environment, where the client would need to make a request to and to decide which particular services or the instance is going to handle the request, and also which services or instances are available and going to take that particular load. So this is where the client side load balancing comes in picture. Now client side load balancing is nothing but it will involve certain client applications which will have their own dedicated um, I mean, it's a client application which will manage the distribution of certain requests to the multiple services, basically. So uh, that's how it will work. So client will be aware of like all the services instances, and then they will use algorithm like round robin or wait routing to decide which of this particular instances we are going to send the request to, right? So what the advantages is that it will reduce the number of centralized load balancers, and it will also helps to scale of the routing responsibility to the client, basically. Okay, so that's what the main advantages is about. Now let's say microservices client, right? API client, let's say querying a certain request, it will query the service registry for the any of the available instances, and then it will find that, and then it will direct that particular traffic to that particular instance based on the either round robin or the wait routing strategy algorithm. Now sidecar pattern, this is basically used to help as an helper service basically, so or the process that will be running as an alongside to the main services basically, which is going to either handle certain cross-cutting concerns like monitoring, logging, or security. Now, this will what will help is that it will decouple your certain non-business logic related things from your core interfaces or the core services microservice logic, which will make it in a separate process, I would say. So this will involve certain deploying your this helper services as a separate process along the main application in the main in somewhere in the same container basically, or in the same host basically. So which will handle certain cross-cutting like as I mentioned, logging, monitoring, security, or communication, so that it will run along the main services to. So what will happen is that if you are separating this, it will allow your main services to be focused and designed around your functionality, or on the core logic, instead of having this particular cross-cutting concerns involved in it, right? So that's how it runs. So a separate process is, but it is going to be tightly, it will be definitely a separate process, but it is going to be a tightly coupled process to the main process, because it will be sharing the same environment or same resources or the same life cycle basically. So what it will manage the routing, handles retries or etc. Provide some certain proxy for the communication between the microservices. Uh, Hope this actually was able to explain you uh, what are the design pattern used in.